Layoffs in tech have many concerned about the industry's changing landscape.
Experts are weighing in about the fear of artificial intelligence.
Google just shattered everything we thought we knew about AI efficiency. They've created a reasoning system that solves complex problems using 90% fewer resources than current giants, and it was built in just 72 hours using consumer-grade hardware. But that's not all. They've also unveiled two revolutionary models, an image generator that creates photorealistic content in milliseconds, and a language model that understands context better than anything we've seen before. This isn't just an upgrade, it's a complete paradigm shift. Let's dive in. All right, let's kick things off with Project Nexus. You know how current AI models work, right? They're like students cramming for an exam, throwing massive amounts of computing power at problems and hoping something sticks. It's the brute force approach, and honestly, it's been working, but here's the thing. It's incredibly wasteful. These models consume enormous amounts of energy, require hundreds of GPUs, and still make basic mistakes that a human would catch immediately. Google's research team looked at this mess and asked a simple question. What if we're doing this completely wrong? Instead of making models bigger and hungrier, what if we made them smarter and more selective? That's exactly what Project Nexus does differently. Think of traditional AI like a person trying to solve a puzzle by examining every single piece individually, one after another in painful detail. It eventually works, but it takes forever and wastes tremendous effort. Project Nexus, on the other hand, is like a master puzzle solver who glances at the box cover, identifies the corner pieces first, and builds strategic clusters before connecting everything together. Same end result, but with elegant efficiency. The secret sauce here is something called adaptive reasoning networks, or ARN for short. Unlike conventional models that process information in rigid sequential steps, ARN creates dynamic reasoning pathways that branch and merge based on the complexity of each specific problem. When it encounters something simple, it takes shortcuts. When it hits something complex, it automatically allocates more computational resources to that specific area. Here's where it gets really interesting. During training, they didn't just feed it problems and solutions. They created what they call reasoning tournaments, where multiple solution approaches compete against each other in real time. The system learns not just what the right answer is, but which path to that answer is most efficient. It's like having an internal debate where the best argument wins, and over time, the model gets better at picking winning strategies from the start. The infrastructure challenges were absolutely insane. We're talking about coordinating thousands of parallel reasoning processes, each one potentially branching into dozens of sub-problems. Traditional training setups would collapse under this complexity. So Google built something they're calling the Distributed Intelligence Grid, a system that can orchestrate 75,000 concurrent reasoning threads while maintaining perfect synchronization. The breakthrough came when they realized they didn't need massive GPU farms. By using smart load balancing and predictive caching, they could run the entire system on modified gaming hardware. We're talking about RTX 4090s and consumer-grade processors, not enterprise-level supercomputers. The entire Project Nexus was trained using a cluster of 48 high-end gaming rigs that you could literally buy at Best Buy. But the real innovation is in their reward system. Traditional reinforcement learning rewards models for getting the right answer, period. Doesn't matter if they took the scenic route or stumbled around for hours. Project Nexus uses something called efficiency-weighted reinforcement learning, or EWRL. The model gets bigger rewards for solving problems quickly and elegantly, not just correctly. Over time, this creates a system that's naturally optimized for both accuracy and speed. The results are mind-blowing. On the global bench reasoning test, Project Nexus scored 94.2% accuracy, while using only 12% of the computational resources of comparable models. On mathematical reasoning tests, it outperformed systems that are literally 500 times larger. But here's the kicker. It did this while generating solutions that human experts rated as more intuitive and elegant than brute force approaches. What's even more impressive is the transfer learning. Even though Project Nexus was trained primarily on logical reasoning tasks, it showed remarkable performance on creative writing, scientific analysis, and even artistic interpretation. That suggests the efficiency principles it learned create a more general form of intelligence, not just optimized shortcuts. When researchers analyzed its internal processes, they discovered something unprecedented. The system had developed what they're calling meta-reasoning patterns. Essentially, it learned how to think about thinking. Before tackling any problem, it spends a fraction of a second analyzing what type of problem it is and selecting the most appropriate reasoning framework. That's not something they programmed, it emerged naturally from the training process. Now, while Project Nexus is revolutionizing how AI reasons, Google has simultaneously launched two other breakthrough models that are already changing the game. Let's talk about PixelForge first. PixelForge is their new image generation model, and it's absolutely ridiculous how fast this thing works. We're talking about generating 4K photorealistic images in under 200 milliseconds. Most current systems take several seconds per image, and even then, you often get weird artifacts or uncanny valley effects. PixelForge produces images so realistic that even forensic experts have trouble identifying them as AI generated. The magic happens through something called progressive detail synthesis. Instead of trying to generate the entire image at once, PixelForge builds images in intelligent layers, starting with composition and lighting, then adding textures, then fine details, and finally micro details that make everything look natural. Each layer is generated by specialized subnetworks that have been trained specifically for that aspect of image creation. What's really cool is how efficiently it runs. While competitors require massive GPU clusters for image generation, PixelForge can run on a single high-end graphics card and still outperform them. Google achieved this by using dynamic resolution scaling. The model automatically determines how much detail is actually needed for each part of an image and allocates resources accordingly. Then there's ContextMaster, Google's new foundation language model. This isn't just another ChatGPT competitor, it's designed from the ground up to understand and maintain context across incredibly long conversations. We're talking about maintaining coherent understanding across 500,000 words of dialogue. That's like remembering every detail of a novel-length conversation. The breakthrough here is their hierarchical memory architecture. Instead of treating all information equally, ContextMaster creates a dynamic hierarchy of importance. Critical information gets stored in high-priority memory that never gets forgotten, while less important details fade naturally over time, just like human memory. But here's the clever part: it can instantly recall forgotten information if it becomes relevant again. ContextMaster was trained on Google's custom TPU clusters, using a dataset that includes not just text, but conversation patterns, emotional context, and even timing information. It understands not just what you're saying, but how you're saying it and when you're saying it. The result is AI that feels remarkably human in its responses. Both PixelForge and ContextMaster were developed using Google's new quantum classical hybrid training approach. They use quantum computers for certain optimization tasks, while classical computers handle the bulk of the processing. This hybrid approach allows them to solve training problems that would be computationally impossible with traditional methods. The philosophy behind all three systems is what Google calls intelligent efficiency. The idea that true AI advancement comes not from throwing more resources at problems, but from finding fundamentally smarter approaches. They're proving that the future of AI isn't about building bigger and hungrier systems, but about building more thoughtful and elegant ones. That wraps up today's deep dive into Google's game-changing AI breakthroughs. If this blew your mind like it did mine, smash that like button, drop your thoughts in the comments, and subscribe for more cutting-edge AI coverage. The future is happening faster than ever, and I'll be here to break it all down for you. Catch you in the next one. Catch you in the